Hello and welcome to another episode of The Art of Engineering. Today we're going to be doing a little bit of antenna stuff, and the reason why we're doing this antenna stuff is because of my trusty old boat anchor, the TS520 Kenwood, which is a hybrid rig, and what that means is basically it means it's got tube finals. So this radio puts out about 100 watts, sometimes more than that, 120, 130 maybe, but I'm going to be running it at about 100 watts. I want to be kind to the final tube so I don't have to replace them while I'm alive. That is definitely a step up from my beautiful Oz QRP, which is 5 watts. And I am not stopping doing QRP. I really love the challenge of it, and I will be using my QRP rigs a lot. But every now and then, I like to take the TS520 for a spin, and having a tiny little UNUN, 49:1 UNUN, feeding into my antenna. Now I have a half-wave N-fed half-wave inverted V, and so I need a 49:1 UNUN, which is a transformer at the end of it, and my UNUN is QRP. So were I to pump 100 watts into that UNUN, I would probably risk damaging the finals in this radio. The UNUN would probably stop working because it would overheat. And there'd be very little power getting to the antenna. So I have run this rig into the antenna at 15 or 20 watts, and it was quite comfortable doing that, but there's no way I'm going to run 100 watts into it. So today, what we're going to do is, well, let me show you. I'm going to stop the video and we'll jump to the bench and we'll have a look. Well, hello folks. The UNUN that I originally made for the antenna was a QRP. I'm going to stop shaking the camera. It was a QRP UNUN, and as you can see, it's quite a small toroid. You've got to make sure these toroids are the correct type for building balans or UNUNs. Otherwise, they're going to become RF absorbers rather than transferring power to the antenna. But what's happened is my mate Chris has given me actually 2 of these. So what I'm going to do is, they should be good for about 50 watts each, so I'm going to stack them up, and I should have a core that's going to be capable of dealing with 100 watts. And then I went to Bunnings and looked in the electrical section, and I was hoping to find a box that would be big enough to house this UNUN. So what I ended up doing was, and it's going to be a tight fit I'm noticing, but I'm hoping that we can get it in there. I'm going to probably be wooing the day that I decided to buy something this big, but anyway, we shall see. What I'm going to do is pop it in there, and then a bit of plumber's tape around here, screw this on, probably spray paint this thing so that it's UV resistant, or more UV resistant, so it'll last a little while. Glue the end cap in. So these are all just plumbing fitments, 90mm plumbing fitments. Go to the plumbing section in your local hardware store. In this case it was Bunnings. I'm not sponsored by them, by the way, so yeah, I'm not getting anything for this. I had to pay for this, but all up, this cost me about 12 bucks, which I'm pretty sure is a reasonable price to be paying for something to house an UNUN or a balan. So it's round, it's going to have its difficulties, but I think I'm going to be okay with it. Anyway, we shall head over to the bench. I shall clean up, and I'm going to show you how to wind this 49:1 UNUN. Now, there's plenty of videos online to do this. This is by no means the definitive way to do it and the best way to do it, but I'm going to show you my bumbling efforts at getting it done. I'm going to use the super glue that I bought. That was all included in the 12 bucks to glue these cores together. I have a heap left over, of course, but you can never have too much super glue. I mean, it's fantastic stuff. I remember my first job when I was the assistant to test engineer at Scitech. I managed to glue my hand to my foot, which he found most amusing, and left me there for about half an hour until he found the nail polish remover and finally allowed me to escape. But I was, there with my hand glued to my foot with the circuit board stuck on my foot as well. Don't ask me how I managed to do that, but if you see how I deal with technical and mechanical problems, you'll probably understand how it happened. Anyway, enough of me, enough of my bumbling along. Let's go over to the bench and start building this thing. There you have it. I'm not going to drill the holes for the counterpoise and the antenna yet because I want to wind my coil and see where it's going to sit inside here. So you can see I'm very organic in my process. You know, stuffed up a little bit on the positioning of this. So what I've done is I've had to recess that a little bit. But you know, it's no big deal. It's still going to all seal and fit nicely. That is the case. We will now glue our toroids together. I tell you what, they don't call it super glue for nothing. I thought I would have a chance to adjust the position of this, but it literally glued it instantaneously. So, word of caution, I have managed to line them, you know, reasonably well. But had I been a bit off, thinking I could slide them into position, I would have been in a lot of trouble. So there you have it, our core for our 49:1 UNUN, and yeah, it's a little bit off, but not too much.
Very shagadelic.
Well, now is the dire moment where I find out whether I've got enough of this wire. So what I'm going to do is I've bent back about, it's close to about 30 centimeters of a wire back on itself. And that is what will be what they call the bifilar. Now, how do I know how much? Because obviously this is going to be a little bit hard to feed through the core, and it'd be nice to know roughly how much wire we need. So what I'm going to do is, and I'm sure there's a better way of doing this, but this is the way I'm going to do it because it's always the clumsy way that I do everything. I've got some wire. You could get a bit of string. It really doesn't matter. And you can actually do a mock-up of the winding that you're going to perform on the actual toroid. So what you need to do is you start with the doubles and you do 2 windings, and then you continue on until you've got 14 windings on the core. So this will tell you roughly how much wire you're going to need. You could do just a few turns and then do a rough guesstimate, or you can just mock up the whole thing. So that is my distance for 7 turns. So we need double that. So we've got our trusty tape measure here. 72 centimeters. So we can say approximately 144. As fate or luck would have it, I've just taken all the wire off the core because it was about 15 or 20 centimeters more than what I need, and you know, if I've stuffed up and I cut it too short, I'm going to leave myself in a bit of a dilemma. So rather than have to like dick around with you know, having to join on bits if I've stuffed up, I'm using all of the wire, and if there's a reasonable amount left over, I'll wind it back onto the spool. But now we are going to do our little twisty. Now I've seen a lot of people do this by hand because they're worried they're going to damage the enamel on the wire, which is fair enough, but I'm going to be as careful as I can be. We're going to be stripping the end of this wire anyway, and that gives us a fixed point, and we are going to do this by hand. So the people that I've seen doing it by hand probably did it by hand for a very good reason, because you've got that opportunity to destroy your wire if you do it using a machine. this is probably a lot safer. So we will just play it safe, and this way we don't strip all our enamel off our coil, and we don't have issues with loss of insulation and shorting out of our coils, because the transformer is not going to work as it should were we to do this incorrectly. And I'm just hoping that I have enough to get the number of windings that is required. If not, I'm going to be really pissed off. So now what we want to do is we need to start our winding, and we need to do 2 primary, and then the rest is a single wire. So every time it goes through the center of the core is 1 turn. So that's 1, nice and tight up against the core, and then the next one will be as it goes through 2, and we've got a whole lot of wire here. It's going to be a real pain in the ass, so we've got to try and make sure that we don't kink our wire. Sorry if I'm out of shot, but I am wrestling with the giant copper anaconda. There's probably an easier way to do this, but we will get there. And we will use our trusty little zip tie to hold our first couple of turns in position. And now that we've got those first 2 turns, we now need to continue on. So this is the completed winding. We start with our bifilar winding, 2 turns. So that's going to be going to, this is earth and counterpoise, and this is going to the center conductor of our BNC. And then we go, so we go 1, 2, then it goes 3, 4, 5, 6, and then we get to the next turn, which goes across. You can see there it goes across to the other side, which is 7, because it's still going through the center. Anytime you go through the center, it's a turn. Then we go 8, 9, 10, 11, 12, 13. Last time we go through the center is 14, and then we come out this end, and this is going to be where our end-fed antenna is going to be connected. So now what we need to do is get these, we need to cut that loop there and get these wires sanded back and tinned. And you can use a blade to strip this back, or what I usually do is I get some really rough sandpaper and I give them a really good sand. And of course, I would advocate also just metering it out and making sure that you have actually gotten rid of all the insulation. And then this is going to go into its little box, and hopefully that's not going to be too much of a struggle. And I'll probably bed it down in a bit of silicone or something to hold it in position. And yeah, we'll have our 100-watt balun ready to go. Just to keep windings in their place, like I did with the primary bifilar, to sort of hold it in position. On my last loop, I've also thrown a bit of a cable tie on there just to hold it in position so that it's not going to go creeping across the coil. And yeah, ready to go. And now we'll just drill our holes for our posts for our antenna. And yeah, as usual, not worrying too much about where they end up. That's looking good. Ooh, that was close. I know it's a masonry bit, but it's probably the right size, so we're just going to, in plastic it shouldn't be a problem. We need to cut down this screw a little bit so it doesn't protrude so much into the case. So we can tell that I couldn't wait till the paint dries, as usual. I've just put some exterior white paint on this so that it'll be okay with UV. When I get it all built, I'll just throw a bit more on it. It's rough and ready, but hey, it'll keep it going for a few more years. There are a few holes in the bottom of it too. It'll be hanging upside down. If any water does get in, it's able to get out, because we know no matter what you do, moisture's going to get in. And sorry about the noise in the background, I'm listening to a net on 7 megs. Anyway, we'll continue on. So what I have decided to do with this UNUN, because I know things will go wrong, they always do, I put some tape here so that when we screw this down it'll be reasonably watertight. I have put weep holes in it anyway, because we all know that water will get in anyway, as it always does, and you know, condensation and whatnot. And this push-in fitting, I was going to glue it, but I've decided that because this is the side where I need to get to how things are wired up in case a wire pops off or something goes wrong with it, I will push this in and just tape it in position. And then the part down the bottom where it sits, where the toroid's actually sitting, I will bed that into some silicone, so it'll have a little bit of a support. You know, silicone will come off if I need to twist this off and rebuild this thing. Looking into the future, so what we've done is we've wired our earth to our counterpoint there, and we've also got our antenna connection here. Now the problem I always have is that I don't have a high power iron, and I would advocate getting one, and I will in the future. I've just cranked my iron as high as it'll go, which is probably not that good for it, but I'm in the market for a new one pretty soon anyway. But I've really tugged on these connections and made sure that they are mechanically stable. Hopefully they're also electrically okay. We shall see what happens when we put some RF through them. I am running out of daylight, so we've got to move quick. Out with the old and in with the new. And there you have it, rough and ready. I am going to have to come back up here and replace all this rope because it's affected by UV, but we've used more of it again because it's all we've got. But I will come back here. There's not a lot of weight on this antenna. It's a very, very lightweight wire, and it's probably a good thing because it gets a bit of a bashing, and obviously, hey, dodgy as insulators as well, so they all need to be replaced as well, but it's a work in progress. So, an adventure and a half. I got up on the roof and realised that I hadn't put the 100 picofarad 4 kilovolt capacitor, and the capacitor's put in that 49:1 UNUN to help it operate on the higher frequencies. There's other things you can do too, because as you go up in the harmonics from 3.5 to 7 to 14, you tend to find that if you want the, say, the CW portion of the band, as you go up in frequency, you'll find, and down in wavelength, you'll find that that resonant frequency creeps up until it's not where you want it to be. So there's ways of playing around with that. There's coils you can put in the antenna and whatnot. I may play with all that at some point in time. At the moment, I'm very happy that it transmits barefoot, or it was transmitting barefoot with the QRP UNUN. So I'm assuming that we're going to have the same situation, but we'll wait and see when we run it on the Nano VNA. But I will down the track, if I want to play around with 14 and whatnot, I may very well have a play with putting some coils in the actual antenna to try and push that resonant point around. Having said that, the TS520 because it's got tuned finals and valve finals, there's a little bit of, even though it hasn't got an antenna tuner in it, there is a little bit of play with SWR and whatnot, peaking power. So I have found that it does let me get away with a little bit of murder. I do know it runs barefoot so far, obviously below 20 watts because of this low power, but it was working fine on even on 14 megs. As long as I didn't have too much power on it, it was behaving itself. So you might find you can tweak and prod it where you want it to go. I do want to get hold of a really old school ATU. I'd love to get hold of an old school ATU with manual tuning, Pi network maybe. So that's the next thing that I'm keeping an eye out for, to sit next to this. It would be really, really nostalgic on my part to have something that I can play with like that. I've got to say, there's a lot of people say it's a pain in the behind, in the hiney, to actually have to tune a valve final. I find the more knob twiddling I can do, the more satisfaction there is in the whole process of actually operating the gear. So for me, at any rate, I've really enjoyed dipping plates and peaking drives and all that sort of stuff. It's been a long time since I've been able to do it, and I highly recommend it to everyone that even loves high-tech stuff, to have at least one boat anchor in their shack that they can play with, because it's a little bit of radio history and it's an exciting thing to do. Anyway, enough nattering from me. I'm going to chuck the Nano VNA on this and have a look at what's happening. Okay, so please pardon the less than perfect sound in this video. As usual, microphone battery is flat. As you can see here on the Smith chart, our nominal impedance is it's roughly 37 to 40 ohms or so, and we have a point of minimum SWRs. 1 is to 1.42 at approximately 3.510. So down in the bottom of the 80 meter band, which is where I want it, so I can work CW. So yeah, it climbs up after that, but when it gets to a maximum of say 2 and a bit, which is what the TS520 is supposed to be working into, that's at 3.670. So I can still work phone on this antenna straight into the antenna without an ATU, and tweaking the tuning on the TS520 seems to be getting me better power transfer even further up. So happy days on 80 meters. And here we have the 7 meg plot. This is scanning 6 to 8 megs and resonant point at 7240. If I go to the bottom of 7 megs, which is just there, SWR is at about 2.5. It's a little bit higher than I would like it to be, but comes down pretty quickly once we get up to about 7.040. So I'd still be okay working into this antenna barefoot. Bit precarious at some points. It'd be nice if I can scoot that a little bit lower. So I may very well be playing with a bit of inductance on the antenna and dropping a coil in there to try and get it to come down to something that's a little bit lower than that. But still, not too bad. But there's definitely room for improvement. It should be noted that the impedance is around 50 ohms too, so at the resonant point. So 7 megs is really good on this antenna in that respect. But it would be nice to get it a little bit lower. So 14 megs is giving me a feed point impedance that's very high. It's in the 80s, and we're sort of resonant at about 14.56 or so, giving an SWR of 2. So yeah, this definitely needs to come down a heck of a lot. So I will be experimenting with a coil in the antenna, try and get this low point a little bit to the left. And then we'll have a look at, we can obviously get a an acceptable SWR of, you know, 2 and a bit, well below 3, but we'll have to play with it. Or we can just use our antenna tuner. But if we're going to be using 100 watts, we're going to need to get a better antenna tuner. So hey, a good reason to get another piece of gear. Now, as suspected, as we go up into the frequencies above 14 megs, the resonant frequency is creeping up above where it's useful. We've got 22.37 here instead of 21, so we really need to push that to the left, and as you'll see when we get up into the 10 meter band, it's even worse. Now, before we're going from 27 to 29, it doesn't appear to be bottoming out at all. And it would appear that this antenna is dipping around about 29.8. So not much happening on the 10 meter band, and I'm okay with that. The plan is to use this antenna maybe up to 14, up to 20 meters, and for the higher band, as in the higher frequency of 10 meter band, I'm going to play with antennas because, you know, 10 meters is a lovely, very manageable size to have a play. So that will be maybe the next project. That's close to 150 watts on 3.5, so I'm not going to run it at 150. Apparently the computer in the front room was making funny noises, so that is one of the things that you've got to watch out for with higher amounts of power, is that opportunity for TVI and interference to various things. Nothing happening in here, but obviously equipment in the front of the house is getting affected by it. So yeah, we're just going to watch our output, crank it back, and you know, for CW, 150 is such amount of overkill. This is barefoot into the antenna. 1.5 is to 1 for the SWR. Well, if you've lasted till the end of this video, thank you for sticking around. 150 watts on 3.5 megs. I'm not going to run it at 150. 100 watts, plenty of power for me. On CW, it's ridiculous amounts. I won't be running anywhere near that. I'd say, you know, 50 watts on CW is plenty. Anyway, we will have a go at a QSO at another time. Doesn't seem to be many people around at the moment. But 7.3, and hope you've enjoyed this video. Remember to like and subscribe, and I'll see you in the next one.